So as recommended by our book, we're going to first begin approaching these problems by trying to figure out what are all the possible outcomes. That's also called the sample space or the probability distribution. So in here, it's just been simplified to the sum table. So when you roll two dice, two six-sided dice, you could roll a 1 and a 1, and their sum is 2. You could roll a 1 and a 2, the sum is 3. Roll a 1 and a 3, the sum is 4, etc. So if I were to roll a 3 and a 1, that would add up to 4. 3 and 2 would add up to 5. And I'm just adding the row and the column. So if I rolled a 5 and a 3, and I'm just filling in all the possible outcomes. And now we're asked to count those up. So if I have 6, 6, 6, 6, 6, 6, 6 times is 36 possible outcomes. So my probability so far is 36 possible outcomes. And remember, we're looking for the winners over the total possible. In this problem, they are specifically asking me to find the sum of two numbers that is at least 9. So that would include 9, but also anything greater than 9. So here I have 4 plus 1 is 5, and then 2 plus 3 is 5. So that would be 20. Oh, sorry, 10. 5 and 5 is 10. Then this could be reduced. So that would be 5 over 18. Venn diagrams may also be used to solve probability problems. Let's take a look at this problem. It appears that a number of people were surveyed whether or not they liked rap, rock, or country. To figure out how many total people are represented in the diagram, we need to add up all the numbers. So I usually do it by adding the single sections. Then I'll add the double sections, and then I'll add on that part last. So what do we have here? 15 and 4 is 9. 2, 4, 5, plus 9 and 11 is 20, plus 7. So that is 79 plus 7, or 86. So then 86 people are represented by the diagram. So now if we're asked how many people like country, well, all of the people that like country are represented in this pink circle. So I have to add up all 4 of these digits. 8 and 8 are 16, plus 17 is 33. If one person is chosen at random, what's the probability that that person will like rap music? Well, all of the people that like rap music are in this circle. So I have to add up all of these numbers. That's 18, 19, and 24 would be 43. So 43 people like rap, but that is actually out of the 86 people total. Let me just double check to make sure I did that right. 18, 19, and 24 is 43. Okay. If one person is chosen at random, what is the probability that that person will like country or rock music? Now this or is actually a Boolean or. Remember back at the beginning of the year when we did union and intersection? Or is the union. So we need country or rock music. So that's going to be all the people that like country and all the people that like rock. Now there's two different ways to figure this out. If we look at how many people like rock, we have 18 plus 8 is 26, plus another 18, that's 44. All of the people that like country, we have 15, 16, and 17 is 33. Now, if we just go straight away and say, okay, 33 out of the 86 liked country, plus the 44 out of the 86 that liked rock, when we just add those two together, we get 77 over 86. Now, when we take a look at this count, we're going to see we're wrong. So we have 18 plus 11, and then we have 15, 16 here, and another 17 there, for a total of, that's 15 plus 7 is 22, 2, 4, 6, 62 total. Well, when I count them up individually, I get 62, but when I combine them this way, I get 77. I wonder what the difference between 77 and 62 is. 15. Now I wonder why I'm 15 over. Could it be that when I counted the rock, I counted these 15 in green, and I counted them again when I counted the country? So in order for my results to be accurate, I would need to subtract off that overlap that was counted twice. If one person is chosen at random, what's the probability that the person will like country and? So this is the Boolean intersection. Remember when we did intersection and union, and was intersection. Country and rock music. I'm going to clean this up here because this is getting a little difficult to read. So if I'm looking for, what was it again? Country and rock. The people that like country and rock are in this overlap right here. It didn't say just country and rock, because that would be 8. So we have to also include these 7, which should be a total of 15 out of the 86. And now that I look at it, I can reduce the 62. So I'm going to go back and see if I can reduce anything. In this second example, we have a total of 100 people that were asked if they like math, science, or social studies. Everyone answered that they liked at least one. Well, if we just go ahead and start filling in these numbers here, we're going to see it adds up to much more than 100. And in fact, we haven't even filled in this overlap, and we already see that this is 134. So we have to figure out logically where the overlaps occur. We're told that 6 people like all 3 subjects. We know 18 like math and science. So that leaves me with 18 minus 6 is 12. And we know that 12 people like math and social studies. And I'll move this up a little bit so we can see. So the social studies is down here. And if 12 people like math and social studies, then 6 people must only like those two. Similarly, if 10 people like science and social studies, and we have the 6 counted for all 3, then this would have to be 4. So if we have 24 people already accounted for liking math, then we must have a remainder of 32 that only liked math. And here we have 22 people that already said they liked science of some sort in conjunction with another class. And we have a total of 43 that were reported to like science. So that leaves 21 that only liked science. And here in social studies, we already counted 16 people of the 35. So that leaves us with 19 that remain. So now if we were to add up these numbers, 32 plus 21, I'm just doing the big circles first, and 19, we get 12, 72 there, and then from this, and that, we get 22, which brings us up to 94, plus the 6 in the middle. That's the total of 100 people that were surveyed. So I'm just going to clean up my data a little bit. And now let's pursue answering any questions we might have. How many people like math only? Well, that was 32. How many people like science only? 21. If a person is chosen at random, what's the probability that the person will like science and math? So that's this overlap in here. It didn't say only science and math, it said science and math. So that would be 18 out of the 100, or 9 out of 50. If one person is chosen at random, what's the probability that the person will like only math? Well, that's 32 out of 100, and 4 goes into each of those, so that's 8 over 25. If one person is chosen at random, what's the probability that the person will not like science? That would mean all of these people here. So that would be 38 plus the 19, which would be 57. And again, we had 100 people surveyed. If one person is chosen at random, what is the probability that the person will like science or math? Remember, or in Boolean algebra, and that's what this is inclusive. So we're going to have a lot of addition here. So as I add these up, I get 10, 31, and that's 18 and 32. I'm getting 11, 3, 6, 7, 8, 81. If one person is chosen at random, what's the probability that the person will like science, but not math? So let me clean up my doodads here. So we want to like science, but not math. So that would be 25 out of the 100, or 5 goes into each of those. Isn't that 1/4? So back to the problems that we are looking at. A standard deck of 52 cards, 13 ranks, 4 suits, and that would be shown here, ace through 10, then jack, queen, king, in the 4 suits, is shuffled and 1 card is drawn. What is the probability that it is a face card or a diamond? So here we have actually 4 suits, so we have 4 jacks, 4 queens, and 4 kings, for a total of 12 face cards, but then we have 13 that are diamonds. We also have to subtract out the 1 card that is both a face card, the 3 cards that are face cards and diamonds. So, face cards that are diamonds, we have 3. We have 10 that are diamonds that are not face cards, for a total of 13. And then face cards that are not diamond are 9. So, what's the probability that it's a face card or joining, union, a diamond? But then we need to subtract off those that we already counted. Otherwise, we'll have that overlap like we did in the last example. So that leaves us with 22 over 52, which can be reduced to 11 over 26. We have box A that contains 5 blue chips and 4 gold chips. So let me sketch out box A and box B. So in box A, use different colors so I don't impede. We have blue chips and gold chips. Maybe that's more gold. In box B, we have 2 blue chips and 7 gold chips. One of the boxes is randomly chosen, and 2 chips are randomly chosen from that box. What is the probability that both chips are blue? So I could choose box A or box B. If I choose box A, I have a 1/2 probability of choosing that, 1 out of 2. And there are 5 out of the total 9 that are blue on my first pull. On my second pull, assuming I pull a blue, there will be 4 out of 8 chips left in that bag. And again, these are ands. So I have a 1 out of 2 chance of drawing box A, and then my first chip would be 5 out of 9 if it's blue. And if that's blue, then I draw again to get 4 out of the 8 remaining. Or, if I draw box B, I have a 1/2 probability of drawing box B, and there are 2 out of the total 9 chips in here that are blue. So my first pull, I have a 2 out of 9 probability of drawing a blue chip. And then my second pull, I could pull 1 out of 8. Again, these are ands. And so now, let's work through this. 1 times 5 is 5, times 4 is 20. 72 times 2 is 144 plus 2. 72 times 2 is 144, which would leave me with 22 out of 144, and then I can reduce, which is 11 out of 72. Remember that I can only add fractions if the denominators are the same. In the fifth problem, a club has 12 members, 5 boys and 7 girls. If 2 of the members are chosen at random, what is the probability that they are both girls? So in order to figure out the probability that you get 2 girls, the probability of drawing the first girl is 7 out of the 12. And now we have to draw the second girl. But we've already chosen one girl, so we have one less girl and one less member. And when you're multiplying fractions, we could do 42, multiply across, but it's always easier, I think, to work with smaller numbers. So here we can divide those out, which means we have 7 out of 22. If we want the probability of a boy and a girl, we could also draw the girl first, right? So if we draw the boy first, let me erase what I wrote up here. If we draw the boy first, we have 5 out of 12. If we draw the girl second, that's 7 out of the remaining 11. Or if we draw that's boy, then girl, we could do a girl, then boy. It didn't say that the order mattered. So now, starting from scratch, if I draw the girl first, that would be 7 out of 12. And then if I draw a boy, I still have 5 boys to choose from, but there's only 11 people now. So we have to add these together. 35 over 132 plus 35 over 132 is going to give me 70 over 132, and I can reduce. So that's 35 over 66. If 2 vertices of a regular dodecagon are randomly chosen, what is the probability that they are adjacent? So for my first vertex, I could choose any of these. So I have 12 to choose from, and then all 12 would be winners. So that's 12 out of 12 for the first. And now I need to choose a second vertex. So now, let's say I've chosen that one. So now I only have 11 that remain. And of those 11, only 2 are winners. So that leaves me with 12 over 66, which then reduces to 2 over 11. What is the probability that they are directly across from each other? So again, my first vertex, any vertex I choose, is going to be a winner. My second vertex, then, if it has to be directly across, there's only one possible outcome. So the 12 out of 12 reduces, and you're left with 1 out of 11. Sorry, I got to back up because we already chose one of the vertices. There's only 11 that remain. So that reduces to 1. and we have 1 out of 11. So here we have box A contains 2 blue chips and 3 gold chips. B contains 2 blue and 1 gold. C has blue and gold. 1 chip is drawn from box A. If it's blue, then a chip is drawn from B. If the chip from box A is gold, then a chip from box C is drawn. What's the probability that the second chip drawn is gold? So I could choose from box A. If I chose a blue from box A, I write it like this. That would be 2 out of the 5 that are available. And then I go ahead and choose, if it's blue, a chip is drawn from box B. And then the second chip is gold. So from box B, I have 1 out of the 3 chips that are gold. Or, if I drew a gold from box A, that would be 3 out of 5. And if I draw a gold from box A, then I have to go to box C. And I'm looking for the second chip to be gold, which would be 5 out of the 9. So here I have 2 out of 15 plus 15 out of 45. Now remember, I can't add the fractions unless they have the same denominator. So what I could do is reduce. 3 and 5 both go into these, right? And then if I need the same denominator, that would be 5 out of 15. So now I have 2 out of 15 plus 5 out of 15. Now the denominators are the same. I can add them together. If you found this video helpful, please like and subscribe. Smash that like button. You know you wanna. Come on, give it a thumbs up.